Welcome once again to this lesson. Today we are going to talk about permutation and combinations. So under permutation and combinations, we are going to start with permutation first. Right, we are going to start with permutation. Right, the word permutation is one of the possible ordered the word permutation is one of the ordered arrangements or grouping of things, of ordered arrangements or a grouping of things. Right, so the word permutation is one of ordered. Under permutation, order matters. So we will see under combination we will not consider order, but under permutation we are looking at ordered arrangements or a grouping of things. So when we talk of things, we are talking about digits, letters of the alphabet, human beings. So when we talk of things, we refer to digits, that's numbers, comma, human beings. We can also talk about letters of the alphabet. Letters of the alphabet. Then we can also talk about balls, etc. etc. Right? So whenever we are talking about things, we refer to digits, human beings, letters of the alphabet, balls, and so on. Right? So the word order in permutation matters most. As I already said, the word order in permutation matters most, because when we say, let's take for example, we take A, B, C, is not the same as B, A, C under permutation. This order is different to this order, right? So even if we write 1024 is not the same as 1042, even though we have 1024, we have 1024 here, but the order is different. Therefore this one is not the same as this one, right? So the following are some examples of permutation. Example number 1, we can say find the number of different arrangements. Find the number of different arrangements of the letters of the word. Find the number of different arrangements of the letters of the word example. Right, this is an example again. of a permutation. So another permutation in how many ways can two men and three women, can two men and three women stand in a queue, if both men stand next to each other, if both men stand next to each other. Right, this is another example again. Right, now we want to look at how we answer these questions. There are different kinds of such types of questions. So we are going to look one by one how we are going to tackle such questions. Right, so we are going to start by explaining what do we mean by the term factorial. The notation n factorial. The notation n factorial. Right. So we are going to use this notation whenever we are dealing with permutation and combinations. So factorial, n factorial means this is the same as n times n minus 1 times n minus 2 times n minus 3 times up to 1. That's the last term. Right? This is the same as, let's say we are given 5 factorial. This is the same as 5 is the same as n, so it will be 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, 2 and 1, which is the last term. This is what we mean by factorial. Let's say we are given 3 factorial. This is the same as 3 times 2 times 1. Even if we are given 8 factorial, it's the same as 8 times 7 times 6 times 5 times 4 times 3 times 1. Right? So this is what we mean by factorial. But we can use our calculator, our scientific calculator, to punch, let's say we want to punch 8 factorial in your calculator. You just punch your 8 and your factorial, which is in your calculator, and it will give you your answer direct. Let's say we are given, we want to punch 8, then you put second function, there is any factorial in your calculator, which is 40,320. 40,320, then multiplying 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. Right, so this is all about n factorial. Let's move on to another part. Now we want permutation of any different objects. We want to look at permutation of any different objects. Permutation of any different objects. Of n different objects. N different objects. Right. So permutation of n different objects is given by n factorial. So this one, permutation of n different object, is given by n factorial. That's the formula. We just use this one for n different objects. Let's take, for example, we want to arrange ask. We want to see how we can write ask. This one can be written in this form. Then it can be written as a, k, s. then it can be written as KAS. It can be written as KSA. It can be written as SKA. Also, it can be written as SAK. We have 1, 2, 3, 4, 5, 6 ways. So this can be written as in 6 ways. So what are we saying? We can say ask can be written in how many ways? In 3 factorial ways, in n factorial ways, which is 3 factorial, that's 3 times 2 times 1, which is 6 ways. This is the short method of writing the word ask in any different ways. Let's have an example. Find the number of different arrangements. Example number 1. Find the number of different arrangements. Find the number of different arrangements of the letters of the word shift. Of the word shift. Right, solution, number of ways, we said it's 5. 1, 2, 3, 4, 5. 5 factorial, which is equal to, then you can simply punch 5 factorial in your calculator. Simply punch 5 factorial in your calculator. That's 5 factorial, which is equal to 120 ways. So it's 120 ways. Right, as simple as that. Right, another example. This was a Cambridge question. In how many ways can 7 policemen stand? 7 policemen stand in a row during parade. Stand in a row during parade. So during parade, how many ways can 7 policemen stand? So 7 policemen, we have 7 factorial, which is equal to, then we simply punch 7 factorial, 7 factorial, which is 5040. So that will be 5040. 5040. Then another permutation. Right, now we want to look at permutation of n different objects taken R at a time. Of any different objects taken R at a time. Right, now we have a condition. Remember from the previous we have n objects only and it was n factorial. But in this case we have a condition. So we are still concerned with n factorial. But now we want to take R at the time. So in this case we use the formula n permutation R. We use n permutation R is equal to n factorial divided by n factorial minus R, n minus R factorial. That's the formula that we are going to use in this instance. Right, let's take for example number 1. 7 different books are to be arranged. 7 different books to be arranged in 4 empty spaces, in 4 empty spaces, in 4 empty spaces on a bookshelf, on a bookshelf. Right, we want to arrange 7 books in 4 spaces. Remember, there are 4 empty spaces, but we have 7 books. So in how many ways, in how many different ways can this be done? In how many different ways can this be done? How many different ways can this be done? Right, so we have 7 different books, but we want to arrange in 4 empty spaces on a bookshelf. Therefore, we have our solution. We want 7 permute 4, since we have 4 different spaces. Therefore, this can be given as 7 factorial divided by 7 minus 4 factorial, which is equal to 7 factorial divided by 3 factorial. Then remember, 7 factorial is the same as, this is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1. And this 3 factorial is the same as 3 times 2 times 1. So we are going to divide this one and this one. So your answer will be the same as 7 times 6 times 5 times 4, which is equal to, or you can simply divide 7 factorial divided by 3 factorial. Or this one can also be written as 7 times 6 times 5 times 4 times 3 factorial, all over 3 factorial. Then you divide 3 factorial and 3 factorial. That will give you 7 times 6 times 5 times 4. 7 times 6 times 5 times 4 is the same as 840. So this is 840 ways. So you can simply divide 7 factorial divided by 3 factorial in your calculator. It will give you 840 ways, right? Example number 2. Example number 2. How many 5-letter code words how many 5-letter code words can be formed? Words can be formed from the letters of the word, from the letters of the word excluding, right? So excluding solution, how many letters do we have in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this word has 9 letters. Then 5 words. 5 words, it means we want 9 permutation 5, which is 9 factorial over 9 minus 5 factorial, which is the same as 9 factorial divided by 9 minus 5, that's 4 factorial. Then we can simply divide 9 factorial divided by 4 factorial. Or we can simply punch 9 permutation 5 in your calculator. 9 permutation 5 in your calculator to give you the same answer. 9 factorial divided by 4 factorial. 4 factorial. That will give you 15,120 ways. Right, let's move on to another type of permutation. Let's move on to another type of permutation. Permutation of n objects. Permutation of n objects, not all distinct. Permutation of n objects, not all distinct. Right, permutation of n objects, not all distinct. In this case, we are going to have, let's say we have n factorial number of terms that we have. Then we will be having those terms which are the same or which are distinct. So we are going to divide by, let's say we have n1 factor times n2 times n3 up to n, depending on the number of terms which are the same on that question, right? So let's take, for example, example number 1. Find the number of different arrangements. Find the number of different arrangements. Find the number of different arrangements of the letters of the word flow. Right, of the word flow. So what are we going to do here? We can see that we have two distinct numbers here. So number of arrangements, since the letter O appears twice, we are going to say 5 factorial 1 2 3 4 5 numbers that we have, divided by zeros which are distinct, 2 factorial, which is equal to, then we divide 5 factorial divided by 2 factorial. This is the same as 5 times 3, 5 times 4 times 3 times 2 factorial, all over 2 factorial. Then we divide 2 factorial and 2 factorial. 5 times 4, that's 20 times 3, which is 60 ways. So this is how we arrange these letters of the word flow, if we have distinct letters. Right, another example on this one. Another example. Example number 2. Find the number of different arrangements of the letters of the word evermore. Right, so in this word we can see we have how many letters? We have 1 2 3 4 5 6 7 8. We have 8 letters. So that will be 8 factorial divided by, remember, we have n factorial over n1 times n2 factorial, n2 factorial, which means in this case we have how many e's? 1, 2, 3 e's. So that will be 3 factorial times our r's. We have 1, 2 r's, which is 2 factorial. Do we have any other letters which are similar? We have e and r only. So in this case we are going to divide 8 factorial divided by 3 factorial times 2 factorial. So we are going to have 8 factorial over 3 factorial is 3. This is 3 times 2 times 1, and this one is 2 times 1. So that will give us 6 times 2, which is 12. So it's 8 factorial divided by 12, which is equal to 8 factorial divided by 12. And it will give us 3,360 ways. 3,360 ways, right? So this is how we find permutation of any objects, not all distinct, right? I hope you are following. Now let's move on to permutation with restriction. Now we want permutation with restriction. Permutation with restriction. We'll be looking at our consecutive terms. Permutation with restriction on consecutive terms. Consecutive terms. Restriction on consecutive terms. Right, so let's take, for example, in how many ways can the letters of the word, let's take, for example, in how many ways can the letters of the word, flow be arranged if the two zeros are not to be separated, If the two zeros are not to be separated, so there is a condition. These two zeros are not to be separated, so they can be written as 00 FL or FLR, so they can be written as F00 LR. They can be written in the form FLR00 and so on, right? So we want to see how we are going to do this. We can do this by, remember, R we can come here, F can come here, L can come here, and F. So there are a number of ways. So in this case, we are going to count this as 1, 2, 3. The two zeros will be one thing. So it will be 1, 2, 3, 4, right? So in this case, the number of letters that we are going to consider is 4 digits, which will be 4 factorial. Then what is 4 factorial? 4 times 3, 12 times 2, 24 times 1, 24 ways. Since the two zeros are not going to be separated, right? I hope you are following. Example number 2. Find the different arrangements of the letters. Find the different arrangements of the letters of the word "11", in which all the letters E are consecutive. So it means E are not going to be separated, right? So we can rewrite this as E. We can write, we are not going to separate the E's, right? So we have L, V, and N. So the number of ways, this one will be one thing. So we have 1, 2, 3, 4, which will be 4 factorial, and that will be 24 ways. So the number of ways will be 24, right? I hope you are following. Right, another example still on this. Example number 3. Sometimes we might have 2 different letters which are more than 1. For example, find the number of arrangements. Find the number of arrangements. Find the number of arrangements of the letters in the word ellipse. In which the two E's and the 2 L's are to be consecutive. Right, so in this case we are going to rewrite this digits as we have E. The E's are going to be consecutive and the L's are going to be consecutive. So now we have IPE, IPS. So how many terms do we have now? We have 1. This is 1, 2, 3, 4, 5. So that will be 5 factorial. And 5 factorial, 24 times 5, that will be 120 ways. If you punch 5 factorial in your calculator. Right, so this is how we deal with permutation with restriction, consecutive terms. Right, so let's move on to permutation with restriction, starting or ending with a letter. Permutation with restriction, but starting and ending with a letter. Now, that was consecutive terms, but now we are looking at starting and ending with a letter. Starting or ending with a letter. Starting or ending with a letter. Right, example. Right, find the different arrangements of the letters. Find the number of different arrangements of the letters in the word lesser jet in which the first letter is L, in which the first letter is L. So it means L is going to be the first letter, so L is not going to change position, right? So now we are going to solution. So we have laser jet. So L is not going to change position. L is not going to change position. So we are going to consider L as a non-existing letter. So how many letters do we have in this case? We have 1, 2, 3, 4, 5, 6, 7, 8. But since we have 8 letters including L, since L is not going to change position, we are going to ignore L, which means we are going to have 7 letters, 1, 2, 3, 4, 5, 6, 7. So in this case, we are going to deal with the remaining letters only. But on the remaining letters, it's 7 factorial. But we have the letters which are the same. We have E and E, which are the same. Therefore, we are going to divide by 1, 2, which is 2 factorial. And that will be 7 factorial divided by 2 factorial. 7 factorial divided by 2 factorial. 2520 ways. We said 7 factorial divided by 2 factorial. 2520. Right, so this is how we deal with permutation with restriction starting and ending. Let's have another example. Another example. I hope you are following. Right, example number 2. Find the different arrangements of the letters of the word. Find the different arrangements of the letters in the word and the word 11. In which the first letter is E, in which the first letter is E and the last letter is N. At solution. Right, we have the letter, we have 11, the word 11. So our first letter is going to be E and our last letter is going to be N. So we are going to write this as, so this will be the first letter, this will be the last letter, which means we are going to ignore the first and the last since they are not going to change position, but these 4 are going to change positions. So we are going to have 1, 2, 3, 4, which will be 4 factorial. But under these 4 items, we have E, which is the same, so we are going to divide by 2 factorial, which is equal to 4 factorial divided by 2 factorial, that will be 4 times 3 times 2 factorial, all over 2 factorial, and divide this one by this one, that will be 12 is our solution. Right, so this is how we will be dealing with permutation with restriction. Now we want permutation with restriction of human beings. Permutation with restriction, but now we are considering human beings. Permutation with restriction, human beings. Right, example. In how many ways can 4 men, in how many, that was Cambridge typical exam question. In how many ways can 4 men and 2 women stand in a queue if the 2 women must stand, if the 2 women must stand next to each other. If the 2 women must stand next to each other. So our solution, we are going to have women 1 and women 2. Men 1, men 2, men 3, men 4. Remember, these are all different people, but these women must stand next to each other. So it means we are going to consider them as one thing, because they are going to stand next to each other, right? So in this case, we are going to say, how many terms do we have now? Firstly, we are going to have 1, 2, 3, 4, 5. That will be 5 factorial, right? So 5 factorial times, remember these are people, so we can't consider them as one thing. Unlike letters, we know that E is the same as E, right? If they are the letters. W is the same as W because they are letters. But women 1 is not the same as women 2. So these women can change positions. Maybe it can be women 2, women 1. So number of arranging these women's will be 2 factorial. So we multiply this. That will be 5 factorial times 2 factorial. Remember, 5 factorial is 120 times 2 factorial is 2. Then that will be 240. That's how we arrange human beings. Women 1 is not the same as women 2, even though they are going to stand next to each other, but they can change positions, right? So another example, 5 boys example number 2, 5 boys consisting of 2 brothers are to stand in a row, right? In how many ways can this be done? In how many ways can this be done? If the first boy and last, are to be brothers, are to be brothers, right? So if the first boy and the last boy are to be brothers, we are going to have boy 1, then this one boy, 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 and boy 2. This one brother 1 and brother 2. First one and last one are to be brothers, right? So the two brothers can stand in two factorial ways, because brother 1 can be here, but this brother can also be here at the same time. They can swap positions. So these brothers can be arranged in two factorial ways, right? So the other brothers left, the other boys left, can be arranged in 3 factorial ways. So this one can be arranged in 3 factorial ways. So we are going to multiply by 3 factorial, which is 2 times 3 factorial, that's 6, which is 12 ways. So this is how we arrange these boys, so that we have brothers at the first and the last. Now we want to move on to combinations. Combinations. Remember, we were talking about permutations. Now we want to move on to combinations. Combinations. Remember, the topic is saying permutation and combinations. Right, combinations. Right, combination is a selection, of a specified number of things from a large group, group. So under combination, order does not matter. Order does not matter. Remember, under permutation, we said order matters most. But under combination now, order does not matter. So example of a combination. Example of a combination. Example of a combination. Let's take, for example, find the number of ways in which find the number of ways in which 5 questions can be chosen. 5 questions can be chosen from 9 questions. In an examination paper. So this one is an example of a combination. In this case, we'll be using the formula n choose r, which can be written as n choose r. That's the formula for combination. So in this question, in this question, we are going to choose 5 from 9. Then this could be can be written as 9 choose 5. Then you can punch this one in your calculator. 9 choose 5 will give us 9 choose 5 is equal to 126 ways. 126 ways, right? So another example, this can be our example number 1. Another example, in how many ways can 11 football players, in how many ways can 11 football players can be selected from a team of 15? Can be selected from a team of 15 players to play a match. Right, so our solution, remember we said is n choose r, which is equal to 15 choose 11. If we punch 15 choose 11 in our calculator, that will give us 15 choose 11, give us 1365 ways. 1365 ways. So another example, let's have another example under combinations, number 3. That was a typical exam question, Cambridge question. Find the number of ways in which 10 people, find the number of ways in which 10 people can be divided into A, 2 groups consisting of 7 and 3 people. 2 groups consisting of 7 and 3 people. Then B, 3 groups of 4, 3, 2, 4, 3, and 2 people, with 1 person rejected. With 1 person rejected. So that was the question, and it had 6 marks. Solution A. Find the number of ways in which 10 people can be divided into 2 groups consisting of 7 and 3 people. So first one is 10 choose 7. So we have 10 choose 7 multiplied by, and 3 people, we have 10 choose, remember, we have 10 choose 7, we have already used the 7 out of what? Of the 10, which means if we say 10 minus 7, how many do we have remaining? We have now, instead of 10 minus 7, we now have 3 remaining. Choose, how many left? Here we have choose 3, which is equal to 10 choose 7 times 3 choose 3. 10 choose 7, that's 120, times 3 choose 3, that's 1. 3 choose 3 is the same as 1. So that will be 120 ways. So in this case, we have to, if we use 7 first, consisting of 7, we are not going to use 10, choose 3. The remaining will be using 3, choose 3, right? So B, part B, 3 groups of, part B, 3 groups of 4, 3, and 2 people with 1 person rejected. So in this case, the question is saying with 1 person rejected. So the firstly, we reject 1 person, which can be done in 10 ways, right? To reject 1 person, because we don't know which one is going to be rejected. So rejecting 1 person, we can say number 1, we reject 1 person, and rejecting 1 person can be done in 10 ways. First, we reject 1 person, which can be done in 10 ways, right? Then we left here. Then the second part, we now want to select 4. We want to make a group of 4. But 4, in this case, we now want to select 4 from the remaining 9 if we reject 1 person. So we want to select 4 from the remaining 9. So that can be done in what? In 9 choose 4 ways. In 9 choose 4. 9 choose 4, which is 126 ways. 126 ways, right? Then number 3, we are saying 9 minus 4, we remain with our 5. We want to make a group of 3 from the remaining 5. A group of 3 from the remaining 5. This can be done in 5 choose 3. In 5 choose 3 ways. 5 choose 3. And this can be done in 10 ways. In 10 ways. Then number 4. Now we want a group of 2 from our remaining 2, which is 2 choose 2. 2 choose 2. 2 choose 2, remember, we have the same numbers, it will be 1 way, right? Now, what are we going to do now? We are going to multiply, hence the required answer, we are going to multiply 10 ways times 126 times 10 times 1. 10 times 126 times 10 times 1. And that will give us 126 and 2 zeros, which is 12,600. Right, so this is how we deal with combinations. So thank you for watching this video. That's the end of the topic permutation and combination. Enjoy watching my videos. Thank you. Remember to subscribe to my YouTube channel.